This is unit 16.5, direct variation. This is similar to what you learned about direct variation when we learned about ratio, rates, and proportions. So a direct variation is a special linear equation that describes rate of change. Describes the rate of change, which is going to be the same thing as the slope, the constant of variation, the constant of proportionality, those similar terms. Also, direct variation is a relationship such that as x increases in value, y increases or decreases at a constant rate. So again, the constant rate. The constant of variation to you guys is also known as the constant of proportionality. Or slope. Before, the equation you saw was y equals kx. And now instead of k, they use m because you learned yesterday that m stands for the slope. So in the equation, y equals mx, m is the constant of variation. The equation down here in words in the key concept, a direct variation is a relationship in which the ratio of y to x is a constant m. We say y varies directly with x. Here's the equation we care about. Y equals mx. This is a graph of a picture. You'll notice one thing that you want to notice about the graph. The graph of a direct variation is always a straight line through the origin. So notice this goes through the origin, the point 0, 0 in the center there. In order for it to be a direct variation, it has to go through the origin. So the examples. According to a recent survey, about 56% of U.S. households own a current video game system. Games for these systems can get expensive, so many stores offer sales on pre-owned video games. The prices of pre-owned video games at a local store are shown in the table below. Determine the constant of variation. So same thing, I'm asking for the slope, I'm asking for the constant of proportionality, the constant rate of change. So if you notice any constant rate of change, money would go in the numerator and games would go in the denominator. So if you want to compute the increase down, it looks like it goes up $16.50 each time. And the games are increasing by 2 each time. So $16.50 for 2 games. If I want the constant of variation, I'm asking you for the cost of 1 game. So $8.25 for 1 game is the constant of variation. That's equivalent to the slope. You just found m. So if I ask you to write a direct variation equation, I want you to write an equation in the form y equals mx. So insert your value for m. Your equation is y equals 8.25x. The next one is a picture of a graph. Shows the cost of different amounts of trail mix. Determine if the relationship between the cost and the weight of the trail mix is a direct variation. If it is, determine the constant of variation and write an equation. So you have 3 points on the graph. You want to look at those 3 points. The first point tells you that you spend $14 for 4 pounds of trail mix. The other point says you spend $28 on 8 pounds of trail mix. And the last one says it's $42 for 12 pounds of trail mix. You want to determine if the relationship is a direct variation, so you want to find each rate and see if it's equivalent. If you divide, this is $3.50 for a pound. This is $3.50 for a pound. And this is $3.50 for a pound. So answer, is it a direct variation? Yes, it is. Yes, it is a direct variation. Because the ratios are constant. And if you notice about the line, where did the line pass through? And the line passes through the origin. So if you were to identify the constant of variation, you already did. It's $3.50 per pound. And if you were to write the equation, remember the equation is in the form y equals mx. Insert your value for m. In this case, m is 3.5. So you say y equals 3.5. X is your equation. So go to the back. The time it takes to burn amounts of information on a CD varies directly with the amount of information. Write and solve an equation to find how long it'll take to fill a 700 megabyte CD. So again, you have 4 points. It's a direct variation, it's a straight line, and it goes through the origin, and it tells you the CD varies directly. It's telling you it's a direct variation. So you need to find m. You need to find the constant of variation. So you could use any of those points on there if you start from the right. I know this is backwards because seconds is on the y-axis and we're used to seeing it on the x-axis. So in 10 seconds, you can fill 2.5 megabytes. In 15 seconds, you can fill 3.7 megabytes. In 40 seconds, you can fill 10 megabytes. And in 100 seconds, you can fill 25 megabytes. Divide any one of those, and that should give you your constant of variation, your K, your M, the slope, the constant rate of change. They should all be equal to 4. So if you write an equation, y equals 4x. So in your graph, remember, the x-axis runs horizontally. That's the megabytes. The y-axis is the vertical. That's the time. So if I want to find how long it'll take to fill a 700 megabyte CD, I should insert 700 into my equation for x. 4 times 700, which means it takes 2,800 seconds to fill a 700 megabyte CD. Tyler charges his customers $10 per week plus $5 every time he walks their dogs. Determine whether the relationship between total weekly cost and the number of times the dog is walked is a constant variation. So think about it for a second. Every time he walks the dog. So think about the total cost and number of walks. One walk would cost $15. 2 walks would be $20. 3 walks would be $25. 4 walks would be $30. Is there a constant rate of change? Answer? No. No. The ratio of weekly cost to the number of walks is different. For every pair of values. If you divided each pair of values, you would not get the same unit rate, which means you do not have a constant of variation and there is no direct variation. So next one gives you an equation, y equals 40x, represents the distance y in miles an ostrich can travel in x hours. So remind yourself, x is hours, y is the miles. Determine whether there's a constant of variation. So yes, there's a constant of variation. And what is the constant of variation? We're going to say yes. The constant of variation is 40. So in this case, what does that mean? Well, remember, x is hours, y is miles. So in that equation, y equals 40x, it's telling you that this means an ostrich can travel 40 miles per hour. It's giving you the speed of the ostrich. So number 6, the depth of a hole varies directly with the time spent digging the hole. They're telling you it's a direct variation. They're telling you it varies directly. It takes 10 minutes to dig a hole 8 inches deep. We should write that as a ratio. Remember, time should go on the bottom. So 8 inches in 10 minutes. It's asking us to write and solve an equation, so we need to find the constant of variation. So we should divide by 10. This tells me that there's 0.8 inches can be dug in 1 minute. So that is your constant of variation, which means your equation, remember, y equals mx. So y equals 0.8x. Now you can use it to answer the question, find the depth of the hole after digging for 45 minutes. 45 minutes should go in your equation for x. Y equals 0.8 times 45. You multiply, the depth of the hole is 36 feet. Oh, not feet, I'm sorry, 36 inches. The depth of the hole is 36 inches after 45 minutes. And the last one compares to rates. The equation y equals 1.5x represents the relationship between the number of heartbeats y, number of heartbeats is y, and the time in seconds x for a dog. So in that equation of the dog, 1.5 beats per second. The chart shows you the beats of the cat. Can you find the cat's heart rate? Pick one of the points. You can pick them all. They're all going to be the same. Beats divided by time is going to tell me that it's 2 beats per second. Question asks you, which animal has a faster heart rate? Answer, the cat has a faster heart rate. Oops. The cat has a faster heart rate. And that's your direct variation, constant of proportionality, constant of variation.